confusing, especially the one where we need to get like with a half line, and then like, so we need to get something with the half line.
Alex, it was not confusing. Do you know why? Because we solved this exercise, the same exercise in a worksheet before. I solved this exercise especially on Zoom with you. And the one who solved this exercise while we were on a Zoom session, I still remember now, Kalam had solved half of this exercise with me when we were on a Zoom session. And I gave you the same exercise in semester 1 exam. It was a very simple exercise, but you should, whenever you read a geometry question, you should concentrate on every line that you read and apply every line that you read. Because when you apply every line alone, things will be easier. Don't read the question, all of it in one, as one. Just read a sentence by sentence, get the idea of each sentence, and the geometry question will be easier, Alex, okay? So now, as you can see, this is a lesson in which we have a theorem. Who can remind me how many mathematics theorem did we study together till now?
Can I say?
Pythagoras,
Yes.
midpoint, mid-segment,
Mixed segment, midpoint, and Pythagoras theorems.
Yeah.
So we have how many
Like
theorems?
3 theorems by now.
Yeah, till now we have
3 by
studied.
now.
Yeah, till
Three
now.
theorems.
Yes,
Yeah.
yes, thank you. So till now we have studied together in mathematics, in geometry. We have studied 3 theorems together. The first theorem was the midpoint theorem. If we have a triangle and we have taken the midpoint of the first side and the midpoint of the second side, the line joining the 2 midpoints will be parallel to the third side and equals its half. This was the first theorem. The second theorem is the median segment theorem. It is applied only in a right triangle. If we draw the median relative to the hypotenuse, it will be equal to half the hypotenuse. And the third theorem, which is the Pythagoras theorem. The Pythagoras theorem, as you know, is only applied in a right triangle. So to apply the Pythagoras theorem, our triangle should be right. And what does the Pythagoras theorem say? It says that the measure of the hypotenuse squared is equal to the measure of the first leg squared plus the measure of the second leg squared. So these 3 theorems we studied together before. We should always apply these theorems because they are very important in geometry. And as you can see in our lecture 1, semester 2, we are studying a theorem which is called the thales theorem. So this theorem is called thales theorem. Thales theorem is a very simple theorem. It is not a hard theorem. And now we will see what does Thales theorem say. If we have any triangle, so here we should not have only a right triangle. Thales theorem can be applied in all kinds of triangles. So how many triangles do you see in front of you on this slide?
3.
3 triangles, yes. So we see 3 triangles. I will talk about each triangle alone. The 3 of them are similar, but I will take each triangle alone and talk about it. Let's please concentrate from the beginning. So we have a triangle ABC. If we look at the first figure, we have a triangle ABC. On AB, you see on AB, I have taken, yes?
So, maybe I see. I understand. So it needs to be in the same line. So A and C, A and B.
Yeah, let me tell you, Alex, what's happening here in this triangle. By given, I told you that M is a point between AB.
Of AB.
Do you see that I have taken M between AB, between the 2 points AB?
Yes.
And also,
I have a question.
Yes, Alex.
Would it be okay if the point was in the middle instead of like on top?
No,
Like
it's
in the
not.
middle?
No, it's not in the middle. It's taken anywhere on AB, Alex. It's
Yeah.
not a midpoint. It is taken anywhere on AB, but it's not a midpoint. Okay.
Yeah, but can we still put in like the middle since it's a bit less confusing?
No. Don't consider M as a midpoint of AB. It's not the middle of AB. It is taken on
Okay.
AB anywhere. Okay. So
Okay.
on line AB, I have taken a point M, and on line AC, I have
N.
taken a point N. But please pay attention. How did I take M and N? Such that A, B, and M are in the same order as A, C, and N. So if M is taken on AB between AB, N should also be taken between AC. So they are taken both between AB and AC. Then the 3 points AMB and ANC are in the same order. Did you get what we mean by the same order? Both of the points M and N are taken between AB and AC. We cannot take M between AB and N outside AC. No, they should be taken in the same order. So the 3 points A, M, B are in the same order as A, N, C. Okay, guys, did you understand this?
Yeah, miss.
Okay.
Yeah.
So this is the first position of M and N. We can also take the 2 points M and N in a different position. Please look at the second triangle. We have a triangle ABC. I have taken M between AB or outside AB?
Outside.
Outside, yes, outside from downwards. And I have taken N outside AC also from downwards. So I can consider that A, B, and M, A, C, and N are taken in the same order, right?
Yeah.
Yes.
Or I can take the points M and N, not from downwards. From where did I take them? Upwards, right?
Yeah.
So I have taken M upward, so I can say that A, B, and M, A, C, and N are taken in the same order. So here we have 3 positions. Now you will ask me, Miss, how can we know where should we take M and N? Between AB, downwards AB and AC, or upwards AB, AC? This, of course, will be told for you in the given where to take M and N. Okay.
Okay, so it's going to be a given. Okay.
Yes. Yes. Either I will give you the figure drawn, finished, or by given you will know how to take M and N. Of course, you will not guess this alone. You will be given something that tells you the position of both points M and N. Are M and N between AB or AC, or downwards AB and AC, or upwards AB and AC? Whatever the position of M and N is in the 3 positions, what do you see in the 3 figures? Do you see that the line MN is parallel to BC or not?
Yeah, they're parallel. They're all parallel to BC.
So in the 3 positions, in the 3 positions, we will get this. We will get that the 2 lines MN and BC are parallel. So in the second position, MN and BC are parallel. And in the third position, MN and BC are parallel. So in the 3 positions, we will have the 2 lines BC and MN are parallel. BC and MN are parallel. So here in the 3 positions, we can apply a theorem which is called Thales Theorem. When do we apply Thales Theorem? as you can see, I have written if line BC is parallel to line MN, so if these two lines are parallel to each others, then by Thales theorem, what do we have? We have, please pay attention, I start from the vertex A. Do you see the vertex A in the first figure?
Yes.
How do we
Yes.
apply Thales theorem? Thales theorem says that AM over AN, AM over AB is equal to AN over AC is equal to MN over BC. So if we apply Thales theorem, we will get these three ratios that you see in front of you. Let me apply Thales theorem in the second position. I will say AB over AM is equal to AC over AN is equal to BC over MN. So this is how we apply Thales theorem in the second position. Let us apply Thales theorem in the third position. From which vertex should I start? Who can tell me?
N?
No?
A.
A. Here
A.
I started
A.
from the vertex A. Here I started from the vertex A. And here I should start from the vertex A. Pay attention how I'm starting. You can start in two different ways. You can start AB over AM. Then you should say AC over AN. Then you should say BC over MN. Or you can start in a different way. AM over AB is equal to AN over AC is equal to MN over BC. Did you get this, guys? Or I repeat in the last position?
Yeah.
Okay, again. Alex, please apply Thales theorem for the first position, Alex. Tell me Thales theorem in the first position. Tell me the ratios, please.
All right. So if BC is parallel to the line MN, then by Thales theorem we have AM over AB, since AM is with AB in the middle of AB.
Is
And
equal
then
to?
and then we have is equal to AN over AC.
Yes,
And
is
that's
equal
to MN over BC because they're parallel.
Right. Thank you, Alex. Please, I want Abbas.
Yeah.
Apply Abbas Thales theorem in the second position. We start from which vertex?
A.
Yalla, start Abbas.
Okay. AM
No?
over
AB
AB over AM
is equal to
AC
over
AN
is equal to
AM
to BC.
to BC over MN.
Yes, Abbas always start from the same vertex. You start simply, Abbas, follow with me. AB over AM is equal to AC over AN. Then you go to the parallel lines is equal to BC over MN. Okay, Abbas?
Okay.
Okay, I want Fadel. Fadel, apply Thales theorem in the third position. From which vertex do we start?
A and M equal N A E
Fadel.
equal.
Fadel.
Yes.
From which vertex do we start from A, right?
Yeah.
Right, Fadel?
Yes.
Okay, start with me, Fadel. Start with me. Say AB over AM
over AM
is equal to AC
is equal to AC
over AN
over AM
is equal to BC
is equal to BC
over mn.
over M.
Please, can you repeat this, Fadel? Repeat it for me.
AB over AM
Yes?
equal AN
No, you
over
start with Fadel. The first ratio you start AB over AM. Then you start the second ratio AC over AN. Okay, Fadel?
Okay.
Start again, please.
AB
Over,
equal
over.
over AM
Yes.
equal AC over AM
Is equal to
equal to A. NM is equal to
BC.
BC.
No, BC.
BC equal to NM
BC over MN.
over NM.
Okay, listen to me, Fadil. If you start the first ratio AB, the second ratio you should start AC, the third ratio you should start BC. So again, I will say the ratio AB over AM. The second ratio is equal to AC over AN. The third ratio BC over MN. Or Fadil, you can start in another way. I start with AM. If I start AM over AB, the second ratio will be AN over AC. The third ratio will be MN over BC. So if I start with the small ratio, the second ratio should start with the small one also. The third ratio should start with the small one also. Okay, Fadil? Nurjan?
Yes.
Nurjan, please, can you tell me the ratio of the third figure? Apply Thales theorem in the third figure.
Okay. AB
Yes.
over AM.
Yes.
AN
Is equal
over
to.
AC.
No, you start the
equal
first
to-
ratio, Nurjan, with AB, right?
Yes.
Then the second ratio should start with AC from the same triangle. Okay?
Okay.
Again,
Miss, can I try to
Nurjan.
do it?
Again, Nurjan.
AB
Yes.
over AM
Yes. Is equal
is
to.
equal to AC
Yes.
over AN.
Is equal to
BC over
over.
MN.
Yes. Who told me I
MN.
want to try? Who is asking to try?
Miss أنا جاد.
Yes, Jad. Jad, can you apply Thales theorem in the second figure again?
Yes.
From which vertex do you start, Jad?
A.
Start, Jad.
AB over BM.
No. Always start from the same vertex, Jad. AB.
Okay. AB over AM
Yes.
equals to AC over AN
Bravo. Then.
equals to BC over MN.
Right. Okay, Jad. We always start the
Yes.
first two ratios from the same vertex, but the last ratio is equal to the parallel lines above each others. Okay, did you get
Yes.
this? Okay.
Yes.
Thank you, Jad. I want to ask Reina. Yes, Reina. Reina? Reina? Okay, I want to ask Sireen. Sireen? Yes, Sireen, can you apply Thales? Why can we apply Thales theorem in the last position? What helps us to apply Thales theorem? What? Because what?
Because BC is parallel
BC is parallel to
NM.
Yes, because BC is parallel to MN, then we can apply Thales theorem. Okay, Sireen? Okay, from which vertex do you start to apply Thales theorem?
A.
Okay, apply it, please.
AB
Yes.
over AM
Yes. Is equal to.
AC
Yes.